Hello students. Today we are going to discuss and talk about SVM, that is support vector machine. Before going to understand what do you mean by support vector machine, let us quickly recapitulate what do you mean by machine learning and broadly classify machine learning techniques. As we have already seen, machine learning can be broadly classified into three techniques: supervised learning, unsupervised learning, and reinforcement learning. Supervised learning, what does it basically mean? Machine learning model learns from the past input data and makes future prediction as output. If you remember the tagline, it is nothing but train me. All right. So this is supervised learning. So if you look here, an example, you have got a strawberry and you teach the model that it is a strawberry. And when you give an data which is unknown, the model is able to correctly identify whether it is a strawberry or not. This is a simple example of supervised learning. As we know, supervised learning includes algorithms like classification and regression. So, because we are explicitly emphasizing on support vector machine, SVM is used basically for classification and regression techniques. In particular, SVM is used for classification. So don't get confused. SVM is not a machine learning technique. It is used in one of the machine learning techniques, which is classification under the category of supervised learning. Now, why support vector machine? If you see over here, the diagram, what does it show? Why not build a model which can predict an unknown data? So if you see, you have got two different types of fruits, strawberry and apple, which is nothing but your labeled data. If you all remember, labeling is a must in supervised learning. With this labeled data, we will train our model, and then a new data will be given as an input to this trained model, and we will get the desired or predicted output that the new data is nothing but strawberry. This is your supervised learning. So if you see the definition, supervised learning is a SVM is a supervised learning method that looks at data and sorts it into one of the two categories. The categories are nothing but whether it is a strawberry or it is an apple. Why support vector machine? But how does this prediction work? So we will be seeing how this prediction works. We have seen it classifies into a strawberry or an apple, but what happens basically within this, we will see. So support vector machine, what does it do is, if you see, this is your labeled sample, and your label sample data includes your strawberry and your apple. So SVM basically draws a boundary which is nothing but called as your decision boundary. And once the boundary is made, when we are giving new data, which is nothing but the unlabeled data, With the help of SVM, we can correctly classify that new data and we can place that data in the particular set. Let us take an example. We are given a set of people with different heights as well as weight. So this is the sample data set for females where height and weight is given. Similarly, we have got the sample data set for male. Now, before adding a new data point, we are going to plot the male and female data set, which includes attributes height and weight, where weight is plotted on the x-axis and height is plotted on the y-axis. Now we have to add a new data point, and that data point is unknown whether it is a male or a female. So this is the new data point, and we have to correctly place this data point either on the male or female side. So what do? This line has so we draw a line, and the line has the maximum space that separates the two classes. Can you see this blue color line? This is your decision boundary. All right. This can be another possibility of drawing the line. So we have got line 1 and we have got line 2. Now we have to be very careful that the maximum space gets covered on either side of the line. So if you see for line 1, the space on either side of this blue line is maximum. Whereas if you see line 2, the space on one side is maximum. That is the male side as compared to that of the female side. So we are supposed to reject line 2 and consider line 1. So this is the best line that splits the data. So this is the best split. There are some terminologies that you have to be aware when you are studying support vector machine. So the blue color is called as the decision boundary or the line. The green color bidirectional arrow is called as the distance margin, and these which are circled in green are called as your data points. I will be using these terminologies from now on. Line, distance margin and data points. The line, to be precise, is called as your hyperplane, and the data points in support vector machine are called as support vectors. So D plus is the shortest distance to the closest positive point, okay, which is towards the male side, whereas D minus is the shortest distance to the closest negative point. So sum of D plus and D minus is nothing but called as the distance margin. Is it clear? So distance margin is nothing but the sum of D plus, which is the positive point, and D minus, which is the negative point. From the distance margin, we can get this hyperplane, which is nothing but your optimal hyperplane. Based on the hyperplane, we can say that the new data point, which is nothing but your male, belongs to the male category. But what if the hyperplane is not optimal? All right, that is the second criteria, the line 2. So if we select a hyperplane having low margin, then there is a high chance of misclassification. Correct? So for avoiding that, there is something called as transformation. One point to remember, this particular line which is there, which is not able to correctly classify a given data point into the desired data set, leads to misclassification, and such a scenario is called LSVM. L stands for linear support vector machine. So in order to get the optimal hyperplane, there is something called as transformation. Please look at the diagram over here. We have got blue and yellow data points. And if you see, the blue data points are scattered on either side of the yellow data point. So it is difficult for us to have a linear SVM that can correctly classify these two data points. So in that case, we have to give an input, and this input is transformed to a desired output through a kernel. So what does the kernel do? It will take one-dimensional input and transfer that into a two-dimensional output in SVM. So now we get the result. So your 1D input is now transformed into a 2D output. So this was your one-dimensional input, and now what is done? It is transformed into a two-dimensional output, and we can see the optimal hyperplane that is separating both the data points. Now, how to perform SVM for this kind of a data set? So what we have to do is, we can convert your this sample data set. If we are applying the normal category, we cannot get an optimal hyperplane. If you see, the red points are present on either side of the hyperplane, which is not a feasible solution. So how do we segregate these two classes? Again, I told you we will have to use a kernel to perform transformation. So 2D transformation will be now transformed into your 3D, and it is done with the help of a kernel. So here basically we are getting a plane. In 1D we were basically getting a line, and in 2D also we were getting a line. But in 3D, we are going to get a plane, which is nothing but your hyperplane. And this transformation is done through a kernel. Advantages of support vector machine. The first one is high dimensional input space. In this video, we have seen how 1D is transformed into 2D and 2D is transformed into 3D. Similarly, we could have n-dimensional input space which needs to be converted into appropriate output so that we can get an optimal hyperplane. So SVM plays a major role in this area. The next advantage is sparse document vectors. It is nothing but in sparse document vectors, we tokenize, we give a token for each and every word in the document in machine learning algorithms. So in your machine learning algorithms, there are different, we consider there are different documents, and for each of the words present in the document, we perform tokenization, and there your support vector machine is used. The next one is regularization parameter, which is nothing but lambda. And SVM helps us to figure out whether we have got biased data or overfitting of data takes place. Regularizing the parameters is very important so that we get the desired output by fine tuning the parameters so that we get our output in such a way that it is unbiased. A few applications of support vector machine. In real time, SVM is used for face detection, text and hypertext categorization, where sparse documents are considered, classification of images, and in the field of bioinformatics. Thank you.